In this video, I'm going to show you how to factor a special kind of polynomial that is called a perfect square trinomial. And you might see your teacher abbreviate this as a perfect square trinomial, or PST. And I want to show you how that's similar to, but a little different than, your difference of two perfect squares. And so the way the factors work is actually very similar because we have perfect squares going on. But in this case, like what we had in our previous video, where your factors looked the same except one had a plus and one had a minus, in this type of example, your factors are going to be identical and identical in sign. So here's a couple things that I wanted to read to you. Number one, for a trinomial to be a perfect square trinomial, which means there's going to be three terms here, not two. Two things must be true. Number one, the first and last terms of your trinomial will have coefficients that are perfect squares, just like in the difference of two perfect squares, where you start with a perfect square and you end with a perfect square. But here you have three terms. And the middle term is positive or negative, doesn't matter, positive or negative, 2 times the product of the square root of the first time and the square root of the last term. So first term and last term doubled. And so they call this a squared plus or minus 2ab, and always at the end plus b squared. And so that's what your trinomial is going to look like. A perfect square in the front, a perfect square in the back, and the middle is double of what the square roots are multiplied together. Here's a note. Not all trinomials that end in perfect squares are a perfect square trinomial, and here's an example. So I want to show you how to check that you have the perfect square trinomial. So you will see three terms here, which is different than the difference of two perfect squares. We only saw two terms. So you see three terms here, and your first term is going to be a perfect square, and your last term is going to be a perfect square, and this is how you check for a perfect square trinomial. You're going to take the number 2, and then you're going to multiply one of these roots. So one of these and one of these. And if we multiply that together, 2 times x times 3 would give us 6x. Does that match what you had in the middle? And if it does, that means you have a perfect square trinomial. And this is what you write. You write that one root that you had, and you write the other root that you had, and a little teeny perfect square, because it's a perfect square trinomial, and you look at the sign of your middle term. The sign of your middle term is going to be the sign that you use. So a plus here. I'll show you a couple more examples. So here again we have three terms. The first term and the last term are perfect squares, so x times x. 36 could be a 6 times a 6, and so this is how you check for what is called the perfect square trinomial. You want 2 times each of your roots. So we want one of these and one of these. 2 times x times 6 is 12x. Does this match what you had in the middle? It does. Now, sign, even though this says negative, all we need to do is, when I write out my little perfect square trinomial, when I use my first root and my last root, is notice the sign here is going to match the sign in here. So because that was a minus, this is going to be a minus. Okay, I'll show you another example here. We have 9x squared, which would be a 3x times a 3x, and a 4, which can be a 2 by 2. So this is how you check for the perfect square trinomial. You're going to double one of each of your roots. So one root here is 3x. One here is 2. 2 times 3 is 6. 6 times 2 is 12, and I have an x there. I notice that is our middle term. Now the sign is a minus, which means the sign in here is going to be a minus. It's always based off your middle term. And I take one of the first roots and one of the last roots, and that is your perfect square trinomial. Now I want to show you how to check to get your original polynomial by multiplying your binomials together here. So this would mean x plus 3 times x plus 3. So I'm just going to confirm and check that when we distribute, we get what we think we needed. X squared plus 3x here, and then plus 3x there, and then plus 9. Together that makes 6x, so x squared, 6x, and 9 is what we had. And then I'll show you another one. I'll show you this one because it's just slightly more complicated. But this means you have 3x minus 2. Oops. It means you have 2 of them when you write that little square. 3x times 3x is 9x squared. 3x times negative 2 is minus 6x. Negative 2 times 3x is minus 6x, and negative 2 times negative 2 is 4. And again, these middle will combine to make negative 12x. So 9x squared minus 12x plus 4 matches what we started with. So these are kind of fun. You know, if you can find the pattern in math, that's really what the goal is. Now let's see if you can remember the pattern long enough for as long as you need to use it. So perfect square trinomials.